Hello students, welcome to Yupp Master. So in our last class we completed spring force and till now we have completed Newton's law and its application. So in last class I told there will be some frames from which if you try to observe the motion of the particle, analysis becomes simple. So today we are going to talk about other frames also. So there are basically two types of frames. One is inertial, another is non-inertial. Inertial frames are those frames on which Newton's law is applicable. So today we will talk about the frames, and then we are going to observe motion of different particles from different frame. So I'll tell you how to switch frame. So from inertial frame, when you go to non-inertial frame we cannot directly apply Newton's law of motion, so we have to do a small adjustment. So how that adjustment is done, how are the terms involved will come into picture, that we are going to discuss today. So let's start. So go through the definition of the inertial frame. Inertial frame basically a frame from which you can apply Newton's law, or in a simple language if I say if I observe a particle or body from inertial frame, say this is inertial frame, and I observe that there is no net force acting on body, so net force acting on body is 0, and I am also observing that acceleration of body with respect to frame is also 0, these type of frames are called inertial frame, right. So it looks very obvious that we are not getting any force, we should not get any acceleration. But when we go to non-inertial frame, it might be possible that you are not observing any force but you are getting acceleration, or you might not observe any acceleration but you are getting net force. So if this is not matching, the type of frame we are standing on will be non-inertial frame. So this definition of inertial frame: an inertial frame of reference in classical physics possesses the property that in this frame of reference, body with 0 net force, look at this one, body at 0 net force does not accelerate. So acceleration of body must be 0, right. And all non-inertial frame will have same type of relation with respect to other inertial frame, right. So if from one inertial frame I am going to observe any other inertial frame, then I won't observe any acceleration to that second frame or any other frame, right. So from one inertial frame, when you observe another inertial frame, then you are not going to observe any acceleration, right. If this condition is not satisfied, then the frame we are standing must be non-inertial, right. So non-inertial frames, see, a non-inertial frame of reference is the reference frame that undergoes acceleration with respect to inertial frame. So I already clear the definition of inertial frame. How to check whether frame is inertial or non-inertial? We have to check this condition. So we have to check this condition, whether this condition is satisfied or not. If this condition is satisfied, our frame will be inertial. If this condition is not satisfied, our frame will be non-inertial. So all non-inertial frame will have acceleration with respect to inertial frame. So say I have got this inertial frame, let that be S, and from this frame I observe that another frame, say S dash, is having some acceleration. So this is the first point. All non-inertial frame will have acceleration with respect to inertial frame. Second point, while the laws of motion are same in all inertial frame, in non-inertial frame they vary from frame to frame. This we will understand later, right? So laws of motion, what we are applying from inertial frame, that we won't get in the same format if we apply laws of motion from non-inertial frame. Or I can say non-inertial frames are those frames where Newton's laws are not directly valid, right? Now another point, in the classical mechanics it is often possible to explain the motion of the body in non-inertial frame of reference. So if I want to observe the motion of the body with respect to this frame, non-inertial frame, then I need to do a small adjustment. That adjustment will have the unit of force, that is why that adjustment is called fictitious force or pseudo force. So by introducing additional fictitious force, also called pseudo force or inertial force, so directly Newton's law is not valid from non-inertial frame. If we want to apply Newton's second law or Newton's laws of motion from non-inertial frame, I have to do a small adjustment. How adjustment is done, we will derive that later, but for time being, if you are on non-inertial frame, you cannot directly write F is equal to ma, where F is the real force, right? What is the meaning of real force and pseudo force, that we will see later, but I hope these 3 points are clear. So second point I will explain later. Now so let us see what is happening. So when I observe motion from this inertial frame, I observe net force on the body, and according to net force I am going to observe acceleration, right? So if I call this frame as S and let this be particle, I will call this as particle. So this will be the direction of acceleration of particle with respect to frame S, right? If I want to observe motion from this frame which is having acceleration with respect to inertial frame, so let this frame be some S dash, as it is having acceleration, say this has got acceleration in this direction, acceleration of S dash with respect to S, and this is our non-inertial frame because it has some acceleration with respect to inertial frame, non-inertial frame. I want to know what we are going to observe from this frame. I can directly apply Newton's second law from this inertial frame, and now I want to know what I need to do to observe the motion with respect to non-inertial frame. Okay, so I will start with the Newton's second law from this inertial frame. So I can write F net mass into acceleration of particle with respect to frame S. There is no problem in writing this equation. F is equal to ma, I have written with respect to inertial frame, right? And if I look at this term, so acceleration of particle with respect to S dash is acceleration of particle with respect to S minus acceleration of particle with respect to S dash. This I can write relative acceleration formula. So relative acceleration, I can write it this way. So here I need acceleration of particle with respect to inertial frame S. So this term I need, I can rearrange particle with respect to S is equal to acceleration of particle with respect to s dash plus acceleration of particle with respect to s dash, and here it is s with respect to s dash. So actually it is s, right? So s dash with respect to s, relative acceleration formula. A small change in this one. Now, so this I want, if I rearrange, I'll get this term plus acceleration of s dash with respect to s right. Now, if I substitute this one in this equation, then I can write net force is equal to mass acceleration of particle with respect to s dash plus acceleration of s dash with respect to s. I can also write, if I get this term this side, plus minus m acceleration of s dash with respect to s will be m into acceleration of particle with respect to s dash vector. So if you look at the format, this side I am getting two vector terms. If I add these two vector terms, I am going to get mass into acceleration relative, acceleration of particle with respect to s dash. So person is standing on s dash, what he is going to observe, that I am getting this side. So this is relative to s dash. Now focus on this term. This is force. So force can be added to a term which will have unit of force. So that means this will also have unit of force. If you look at the free body diagram, this is the force which is acting on the body, and if we add one more term, we are able to find out the relative acceleration with respect to this non-inertial frame. So this term is having unit of force but which is not acting. That's why this is called pseudo or fictitious. So pseudo or fictitious force, if I add to the actual forces acting on the body, I can find out the acceleration of the object with respect to non-inertial frame. That means I need to adjust this term when I go from inertial frame to non-inertial frame. I just need to add one more term. So if I add this term, I can find out relative acceleration, right? As this term is having unit of force, this is called pseudo force. So this is pseudo. This is the force which is actually acting. So I can write the whole expression as F actually acting on the body, I will call real, then I will call this term as pseudo, force pseudo will give you mass into acceleration relative to non-inertial frame, A relative. That means when you want to find out acceleration of body with respect to non-inertial frame, then you have to add one term which we are calling pseudo force. Let's talk about the direction. If you see here, we are getting minus sign, acceleration of s dash with respect to s. So this is the direction of acceleration of s dash with respect to s. Opposite to that, minus sign is there. So reverse the direction of acceleration of frame with respect to inertial frame and multiply it to mass. So just reverse the direction. So I reverse the direction of this one, and then I multiply acceleration to the mass of the object. Let the mass of the object is m. Then we are getting direction of pseudo force this way, and the magnitude is m s dash with respect to s. So resultant of these two terms, the forces what we observe from inertial frame plus the term we need to adjust as we have moved to non-inertial frame, resultant of these two will give you mass into relative acceleration, right. So direction of pseudo force is opposite to the direction of pseudo force is opposite to the direction of acceleration of non-inertial frame with respect to inertial frame, right. So this we should do when we go from inertial frame to non-inertial frame. So why we want to go to some non-inertial frame? Because analysis may become simple. So just to make analysis simple, we may require to switch the frame, and when we are switching the frame, this is the requirement. That means after adjusting this term, I can avail the facility of Newton's law of motion. I can write total forces, real pseudo is equal to mass into relative acceleration. Real forces are always frame independent. That means the F net you are observing from here, same F net you are going to observe from here. So real forces are frame independent. Important point. Gravitational force, for example. So no matter whatever frame you move, the gravitational force you are going to observe will be same, right. So the real forces are frame independent. From any frame you move to any other frame, you are going to observe same real forces. Now what we explain here, or what we discuss, a second point. See this one, let us understand that second point. When you go from one frame to another frame, obviously all the frame with respect to inertial frame will have different acceleration. If they have different acceleration, if this quantity is different, if this quantity is coming different, then pseudo force here will come different. If this pseudo force comes different, because this will be same for all the frames, if this quantity is different, that means what you are going to observe from different frame will be different. So according to the variation in this one, there will be variation in this one, and this pseudo force depends on the acceleration of the frame. So from inertial frame, when you go to different frames, or different frames having different acceleration, you are going to observe acceleration of the object different. That is the meaning of the second point what was there in the previous slide, right. So according to this one, this term will be different, right. I hope now second point is also clear. Now we will take up some situation to understand the application of this one, right. So I hope all these points are clear. Let's see. So I am taking simplest situation. The most simplest situation is we have got one block attached to a string to an elevator going up with acceleration a0, right. So elevator is going up with acceleration a0, and the person is standing here on the ground. What he is going to observe? So as I already told you, that irrespective of frame what we have selected, forces are going to be same. So what he is observing, that you can easily tell that string will exert pull force, tension T upward direction. If block is having mass m, mg force downward direction, right. As string is attached to the top of the elevator, this block will go with the same acceleration as that of block. This block will have same acceleration as that of lift, right? So this observer observes that this block goes up with acceleration a0. If I call this observer as observer A, so from observer A, so from this frame, what we can write? Simple question. He is observing acceleration and he observed two forces. So T minus mg is equal to mass into acceleration. T minus mg is equal to mass into acceleration. So for this observer, the value of tension is coming T is equal to mg plus ma naught. Okay, this observer, we have written Newton's second law and we got the value of tension in the string. Now visualize the situation that person is standing inside the elevator is or want to calculate the value of tension. So this observer, first what he is going to observe, as he is inside the lift, he is not going to observe any acceleration of the block. He will observe that block is stationary at a particular location, right? So he is not going to observe any acceleration. As his frame is non-inertial, as he is inside the lift, it is going with the acceleration a0, his frame is non-inertial. So as his frame is non-inertial, we need to add fictitious force or pseudo force opposite to the direction of acceleration of the frame. So with respect to this inertial frame, this is our inertial frame and this is our non-inertial frame, right? So this is non-inertial frame. Person is standing on the ground, inertial frame. So for inertial frame, we have written one equation. We applied Newton's second law directly, and to avail the facility of Newton's law from non-inertial frame, as this person is accelerating, this frame is non-inertial frame, I need to add pseudo force. So I added pseudo force ma0, mass of the block, acceleration of the frame, direction opposite, right? So as this person is not observing any motion of the block from observer B, I will call this observer B. So from this observer, as he is not observing any motion to the block, he is going to apply Newton's first law. Summation of all the forces has to be 0. So what he will write, that in downward we have ma0, upward we have mg, downward we have mg and upward we have tension, right? So the value of tension, you can see, calculated by person standing inside the lift is same as the value of tension calculated by person standing on the ground. The values are coming same. That means the last point I discussed in the previous slide, that the value of real forces will be same from all the frame, right? So we need to, because our frame is non-inertial, we need to add fictitious force with the real force. This mg will be observed same by both the observer. So this person will observe that gravitational force is acting in downward direction, and this inertial frame will also observe that gravity is acting in downward direction. Both are observing tensions are in upward direction. observation, if you look at, person is standing on the ground, observes that block is accelerating up, but the person inside the lift observes that block is stationary. So what I am writing here actually is this one. If I simplify this one, then I am writing this as T minus is equal to 0, Newton's first law. Summation of all the forces has to be 0 for it to be observed stationary, right? So from here, if I simplify, we are getting ma naught plus mg. So real force, pseudo force, depending on the situation, depending on observation, you can apply Newton's first law or Newton's second law. But keep in mind that from all the frame, real forces will appear same. Clear? I hope this simple point is clear. Let's take another situation. Previous case, I kept a block attached to the lift directly. In this case, what I have done, I have taken two masses which are connected to the string passing through the pulley, and pulley is attached to the lift. So again, if I ask find the value of tension in the string, question is find the value of tension in the string. As tension is the real force, both the observer must observe the same value of the tension, right? You can solve this problem standing on the ground or standing inside the lift. Let's first write the equation for this observer who is standing on the ground. So for this observer, observer A, I will draw free body diagram. Okay. So string will be pulling it, tension. Earth will be pulling it down, mg. Similarly here tension will be pulling it, T. So these are the two forces observed by observer A. Okay. And if I assume that the acceleration of m1 is in this direction, a1, and acceleration of second block is a2 in upward direction, then I can see there are three unknown. I don't know value of tension, I don't know value of a1, I don't know value of a2. So there are three unknown, we require three equations. So two equation I can make from motion. So from observer A, we can write this observer is observing that m1 is going upward with acceleration a1. So what he will write, T minus m1 g is equal to m1 a1, and this observer will write equation for m2 as T minus m2 g is equal to mass into acceleration m2 a2. But there are three unknown, we require one more equation. So I can also write the equation for constraint, pulley constraint, right, or a string constraint. If lift is going upward with a naught and pulley is fixed to the lift, then obviously pulley will also go up with acceleration a naught. And for such situation we know the formula, AP is equal to a1 plus a2 by 2. In constraint we learned that. So I can directly write a naught will be equal to a1 plus a2 by 2. So second equation will be, or third equation will be a naught is equal to a1 plus a2 by 2. So these are the three equations. If we can solve these three equations, we will get the value of tension. right. So this is what we have done earlier also. Now today we are talking about what we supposed to do if our frame become non-inertial. So I'll place observer inside the lift. As lift is accelerating up, this observer will accelerate up. As this observer accelerate up, what he is going to observe? He is going to observe real forces as it is. He is going to observe real forces as it is, tension and mg as it is, and then m1 a naught and then m2 a naught. Mass of the block, acceleration of the frame, direction opposite, pseudo force, right. So same for this one, mass of the block m2, acceleration of the frame, direction opposite, okay. And if he is observing that this pulley is stationary, because the height of pulley, what he is going to observe will always be same. So he is going to observe that pulley is at rest. If pulley is at rest, then whatever rate with which this string is reducing, with the same rate other side string will be increasing. So if I assume that with respect to this observer, relative acceleration of this block is in this direction, the relative acceleration for this block has to be in downward direction of same magnitude, A relative. So standing inside the lift, he is going to observe that whatever magnitude of acceleration one block is going up, another block will be coming down, right. So motion will be something like this, he is going to observe. Now for this observer, we will write the equation. So from B let us first write for M1. M1, he observes that T acts upward, Mg acts downward. He is going to observe these two real forces. So T upward, M1g downward, and then he observes one pseudo, I will write it later, mass into relative acceleration. Similarly for this one, I will complete the equation later. Similarly for this one, he is going to write m2g minus t, m2g in downward, t upward. So m2g minus t is equal to mass into acceleration m2 a relative, okay. So I will write that with red color. So he is observing relative acceleration a relative, observes a relative for that block to m2 a relative. Now the direction of pseudo force for first case, it is downward. So minus m1 a naught and then m2 a naught, m2 a naught plus or minus m2g I am considering downward. So m2g or m2 a naught plus. So why I am writing this way? Because I want to make you understand that these are real forces which we observed in first case also, and the additional term came into picture. Look at this m1 a naught, okay. This is the force we applied because our frame was non-inertial. So we applied pseudo force. Similarly here, if you look at this one, this is coming here as well as here, and in this case you are getting one term extra, that is representing pseudo force. So as you have added pseudo force, the acceleration you are going to get this side is the relative acceleration, acceleration observed by the observer inside the lift. Okay. Now, whether you calculate the value of tension from first equation or second equation, from observer A or observer B, you are going to get the same result. I already proved that, right. So, solving from this frame or solving from this frame, you are going to get the same value of tension, but the value of acceleration will be different. If you closely look at both the equation, they are same. If I rearrange this one, then T minus m1 g is equal to m1 a naught plus a relative. So, here if I compare this equation with this equation, a naught plus a relative is nothing but a1. With respect to this frame, this is having a relative upward. With respect to this frame, this is having a relative upward. Frame is having a naught upward with respect to ground. So, if I ask what is the acceleration of this one with respect to ground, a naught plus a relative, that is what we are getting here. So, as I told you earlier, from different frame if you write the equation, the term you are going to get here will be different. The term what I am getting from ground frame is A1, A2, but from this frame I am getting A relative acceleration, simple. So, I hope this is also clear. So, the important point we have learned that when we want to find out the value of real force, then irrespective of the frame, the value of real force will come same. So, from this frame T or from this frame T, you can calculate. But when it comes to the acceleration, so acceleration will be different from both the frame. As you can see, person A will observe that this block is going with A1 and this block is going with A2, but the person is standing inside observing that this is going with A relative, other block will be coming down with A relative, right. So, I hope this part is clear, what we supposed to do when we change the frame, right. Now, let us take one more example, simple example. So, we have one wedge over which we kept one block of mass m, right, and according to the question, if all the surfaces are smooth, find f such that block remains stationary with respect to wedge. I want to find the value of f, that means I am trying to find out the value of real force. So, real force value I can find standing on the ground, or I try to find out this value standing on this frame, standing on the wedge, I must get the same value. This is the point we are discussing, right. Now, if I observe the motion of block with respect to this frame, frame A, what I am going to see? So, observer standing on the ground, he will observe that as this wedge moves forward, this block will remain at the same height. So, the position of the block from the ground is not going to change. This is what observer from ground observes, right? If that is the situation, let's try calculating the value of f from this frame. So I can see one normal reaction which is coming on the block, and then I can see one field force mg, and I observe that it is going in horizontal direction, right? So if it is going in horizontal direction, the acceleration of this block and acceleration of this wedge, they are same because there is no relative motion. So with respect to wedge, block is not going down, that means there is no relative motion, they must have the same acceleration. As they have the same acceleration, I can consider the whole thing as one system to get the relation between acceleration and force. So if I consider this as system, okay, first I will erase this. So I am removing these forces. Let's first see what we are observing and how to write the equation. So what I am saying that as there is no relative motion, block is at a particular position on the block, on the wedge, and it is not moving with respect to wedge. This I can consider as system. If this I consider system, in vertical direction, capital Mg, small mg will be acting, normal will become internal to the system, and in horizontal direction there is only unbalanced force. There is no friction here, surface is smooth. So only one force I observed in horizontal direction. Directly I can write F is equal to mass into acceleration standing on the ground. So this is A, acceleration of the wedge and block observed by person on the ground, and we can write F is equal to mass into acceleration. That means from here I can say that acceleration of both block and wedge is F divided by capital M plus small m. Right? And after considering this whole thing as system, now let's put focus on block. On block, perpendicular to the surface normal reaction and downward mg. So these are the two forces observed by the person standing on the ground, right? If this angle is theta, with vertical this angle will be theta. So if I draw free body diagram of M after resolving component in x direction and y direction, I can see here n cos theta upward direction and n sin theta in horizontal direction. As the motion of block is along x direction, I can write n sin theta will provide acceleration. This is from observer A. So from A we are solving the problem. Okay, let's first calculate the value of f, and then we will check whether we are going to get the same value if we observe from the non-inertial frame. From wedge frame, whether we are getting same value or not, we will check. So n sin theta is the unbalanced force acting on the block, this component, and that will accelerate the block. So I write n sin theta is equal to mass into acceleration. Simple, right? As block is not going in y direction, I can say its y component will balance mg. So n cos theta will balance mg. So n cos theta will balance mg. So from these two equations I can find out the relation between A and G. If I divide these two relations, I can see A by G is coming tan theta. That means A is equal to G tan theta. If I write A is equal to G tan theta here, then I will get F is equal to, so here I simplify, then in place of A I am writing G tan theta. So G tan theta is equal to F divided by capital M plus small m. If I simplify, I will multiply this term here, we are going to get this. This is when I am observing motion from ground frame. Now let's go to wedge frame. So from wedge frame, see what we are going to observe. Person is standing on wedge, what he observes? He observes these two real forces. So normal reaction and mg, he is going to observe same, right? As this frame is non-inertial, this was going with acceleration a, then he will add, because he is going with acceleration a, he is going to add pseudo force. And what he will observe, that there is no relative motion. Block remains stationary with respect to wedge. As block remains stationary with respect to wedge, he is not going to observe any relative motion. And if he is not observing any relative motion along x direction and y direction, he will apply Newton's first law in both x direction and y direction. So from observer B, or from this observer, if I draw free body diagram, then as there is no motion in y direction, n cos theta will balance mg. N cos theta balances mg, and n sin theta, you can see here, n sin theta, n cos theta, n sin theta. So no motion is observed, we added pseudo force, now he is not observing any motion. What he is going to write, summation of all the forces in x direction and y direction will get balanced. Y direction we already balanced, let's write for x direction. N sin theta must be equal to n sin theta must be equal to this force. So though it looks F is equal to ma, but this is Newton's first law. I am actually writing n sin theta minus mg is equal, ma is equal to 0. And this equation actually I am writing n cos theta minus mg is equal to 0. So in x direction, y direction, I am applying Newton's first law. But here what I did, in x direction I apply Newton's second law. So this is Newton's second law, but in y direction I apply Newton's first law. So after rearranging, you will see that equations are coming in the same way, but they are different equations. So from this frame also I am going to get the same relation, that is A by G tan theta. If I divide these two, then we are getting A by G is equal to tan theta. Right? A by G is equal to tan theta, and substituting the value of A from here, I'll get the value of force, and you can see we are going to get the same value. So the point was that the value of the force, whether I calculate from inertial frame or non-inertial frame, I am going to observe the same value, right? So it depends on you whether you want to solve the problem standing on the ground or you want to solve the problem standing on some non-inertial frame, right? Result will be same, but only thing, when you are on non-inertial frame, you have to add one force which is called fictitious force or pseudo force. Now let us see another example. So I hope up to this point everything is clear. Now look at this situation. So there is a ball suspended inside a cart. Ball suspended inside a cart, and if cart remains stationary, the system, if whole system is stationary, then string will be vertical, right? But if cart is accelerating, so point of suspension will also accelerate. So this will also accelerate. So person is standing on the ground, what he is going to observe that at right now T is in this direction, mg in this direction, right? And if cart moves little forward, then component of tension start coming into the bob, right? So tension will come into picture if cart moves little forward. So bob start going in forward direction, right? And at equilibrium, finally what happens? This is the final situation. In final situation, bob is making some angle theta with the vertical, right? And I want to find out this angle. So now I have got two options, whether I be on the ground and observe the motion of bob, or I be inside the cart and observe the motion. If I am on the ground, I will observe these two forces, one tension in this direction, one mg in this direction, and I will observe that this ball is going this way with acceleration a. So same as the previous one, in y direction ball is not going, ball is going in x direction. I will resolve tension in two direction, t cos t sin. So one equation I can write t sin theta is equal to mass into acceleration, and another equation I can write t cos theta will balance mg. So this is Newton's second law. Now I am writing Newton's first law, t will be balancing mg. So if I divide these two equations, we are getting tan theta is equal to a by g. Simple. This is from observer A. Now if I want to calculate the value of theta from this observer B, what he is going to observe, that person is standing inside the cart, what he is going to observe that string makes fixed angle theta and bob is hanging at particular location. So person is standing inside the cart is not going to observe any motion. as his frame is non-inertial frame, he will add pseudo force here. So what he will write, see, from frame B, as Bob is stationary, he will apply Newton's first law in y direction as well as x direction. Y direction, see, t cos theta is balancing mg, so he will write t cos theta balances mg, Newton's first law. In x direction also, he will write t sin theta will balance ma. If you divide these two, again you are going to get the same relation. So you can calculate value of theta standing on the ground or getting inside the cart. As cart frame is non-inertial, we need to add pseudo force opposite to the direction of acceleration of frame. We need to add pseudo force, and after applying Newton's law, we are getting same answer. So I have the now I feel that whole point is clear, right? So real forces are frame independent. Any frame you are calculating the value, you are going to get the same answer. And such type of thing like angle and all, you calculate from the ground frame or you calculate from the moving frame, you are going to get same, right? So you have the choice whether you be on the ground and observe the motion, or you be on the non-inertial frame and observe the motion, right? So all basic point I cleared today. In the next class, we will take more problem to understand the application part of this non-inertial frame, right? So I hope you all enjoyed today's class and you understood all the thing what I taught. Thanks very much for watching.